simplify the boolean function using boolean algebra laws. So the boolean function is this. We have f is equals to not a and b and c, or a not b c, or a b not c, or a b c, or a b c, or a b c. So that is the boolean function. We are told to simplify it using boolean laws. So first of all, here you have to apply all the laws where possible to reduce the function, be it distributive laws, absorptive laws, identity laws, etc. So let's proceed. First of all, when you consider the last two terms, we have some of the variables that are common there. So first of all, we are going to apply what we call the idempotent laws. So the idempotent law says if we have a and or a, we get a. So the last two terms can be factored, and we have the expression as not a bc, or a not bc, or a b not c, then or a b c, or we factor out bc and we have a or a. So this a or a, using the idempotent law, we are going to get a. So the new expression will now look like not a bc, or a not bc, or a b not c, or a bc, or this a we multiply with bc, we get also a bc. As you can see, these two terms, we can apply the same law. So idempotent law still is applied of a or a is equals to a. So we are going to do the same as we have done in the previous step, and as we do that, we shall have these two shall be factored out. We factor bc and we have a or a, and because this will give us a, so the term will resort to abc. So the new expression will reduce these two terms to abc. So now our new term will look like we have to write it up to that point, then we add this term. So we have a, that is not a, bc, or a not bc, or a and b not c, and we have a and b and c. Now with that expression, let's use the distributive law. Distributive law means AB plus AC, for example, will give us A plus B plus C. So in this case now, when we apply the distributive law from the previous expression, we shall have BC then A that is not A or A inside. We have just factored this. Then we add A not B, C, and we have A B, C. That is not C. So we have that. Let's use the complement law. Complement law means A or not A, we give 1. So this one will result to 1. So we are remaining with BC and 1, or A not BC or A B not C. Then let's use what we call identity law. Identity law, here we are going to say A and 1 we get A, and that will apply in the first term. So we get BC or A not BC or A B not C. Let's use distributive law from this step. So distributive law will give us, we factor C out in these terms. So C, we get A not B or B, and A B and not C. When you consider these two, so from here we are going to use what we call absorptive law. And absorptive law means if we have, for example, here the absorption law will apply in that not A B or A. In this case now here, the B will be absorbed and we get B, we get B or A. So one of the S is absorbed. So in this case now we are getting a C into A or B, then plus A B not C. Let's distribute this. We get CA or CB or ABC. Then also let's use absorption law in this case, whereby we are going to use these two terms, whereby we are getting let's have that. So we are having CB and we are not going to consider these two. We are considering the first one and the third one. So we have CB, or we factor A out, which is common, and we have B not C or C. Then using the concept that we have used here, we'll remain here with B or C. So C complement will go. So we shall remain with CB or A into B or C after absorption law. So distributing this, we are going to have CB or AB or AC. And at that point, now this one cannot be simplified any further. And that will become the final expression after simplification.